That first image ever acquired from orbit around Mercury was amazing. When it finally came in, it looked perfect. It looked exactly like we expected it to be. For me, that was the real moment when I realized that we had successfully made it into orbit and everything was working.
NASA just exposed a terrifying secret hidden by the depths of space itself, right on Mercury, our solar system's enigmatic neighbor. Perched perilously close to the sun, this tiny planet may look unassuming, but beneath its crater-pocked surface lies a heart of darkness, and possibly diamonds. What daunting truths are lurking beneath those alien plains? Brace yourself as we delve into the mysteries that Mercury conceals, unveiling secrets that are as dazzling as they are dark. Mercury's hidden gems. For centuries, Mercury remained an elusive blur in our telescopes, a mere speck of mysteries untold. But now, armed with cutting-edge technology from the James Webb Telescope and other missions, we've begun to pierce this veil of shadows. Recent findings hint at the unthinkable, diamonds scattered within the bowels of this broiling planet. But the surprises don't stop there. Mercury's core, vastly larger and more bizarre than anticipated, challenges our understanding of planetary science. As we explore deeper, what other spine-chilling secrets will we unearth from this fiery world? For a long time, its landscape was a mystery, but as technology improved, we started to uncover its secrets. The first major step in exploring Mercury came with NASA's Mariner 10 mission in 1973, followed by the Messenger probe, which launched in 2004. As it flew by, it took pictures that showed a surface covered with craters and strange ridges, a bit like our moon. The mission revealed that Mercury has a rough, cratered surface, a surprisingly strong magnetic field, and a larger core than anyone had expected. These discoveries made scientists rethink what they knew about Mercury. Then, 31 years later, the Messenger probe, specifically designed to orbit Mercury, gave us an even better look at the planet. Unlike Mariner 10, which just flew by, Messenger stayed in orbit around Mercury, allowing it to gather a lot more information. During its mission, Messenger captured over 200,000 images, showing us parts of Mercury that had never been seen before. One of the most interesting things Messenger found was the high levels of calcium and magnesium on Mercury's darker side. This discovery made scientists question how these elements ended up there. The probe also found that Mercury's magnetic field was unusually strong in the northern part of the planet, which is different from what we see on other planets. On Earth, magnetic fields are created by liquid iron moving in the core, but Mercury's unique interior leads to different magnetic behaviors. During the day, temperatures can reach a scorching 806 degrees Fahrenheit, hot enough to melt lead, while at night, they drop to a freezing minus 292 degrees Fahrenheit. This huge temperature swing happens because Mercury's thin atmosphere can't hold on to heat. Even with these harsh conditions, recent studies have found some surprising features on Mercury's surface. In 2012, data from Messenger revealed evidence of volcanic activity on Mercury, including signs of explosive eruptions. This discovery challenged the old belief that Mercury was a geologically dead planet. But that's not the most surprising part. In 2020, scientists announced they had found water ice in some of Mercury's polar craters. These craters are so cold that they can keep water ice frozen, even though Mercury is so close to the sun. This discovery has sparked even more questions, like whether there could be simple life forms on Mercury, despite its extreme environment. Could any living creatures survive on Mercury, like those tough organisms we find in Earth's most extreme environments? Imagine something living in the cold, icy spots of Mercury. The Bepi Colombo mission, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is on its way to Mercury. It will arrive in 2025 and is expected to give us a close look at Mercury's surface, revealing its chemical makeup and its geological history. Mercury always surprises us with new discoveries, like its strong magnetic field and the presence of water ice. Let's explore Mercury, a planet where days and years don't follow the usual rules. A day longer than a year. But the next discovery might be even more surprising. How can a planet so close to the sun have a year shorter than a day? When we think about how planets move, we usually assume that a planet spins once on its axis each day and orbits the sun once a year. But Mercury doesn't follow this pattern. On this tiny, sun-scorched planet, a year is shorter than a day. Let's break this down. Mercury orbits the sun in just 88 Earth days. Because it moves so quickly around the sun, a Mercurian year is much shorter than a year on Earth. What makes this even more interesting is that a day on Mercury, meaning one full rotation, lasts about 176 Earth days. So, a year on Mercury is only half as long as a single day. This strange time pattern leads to some odd events. If you were standing on Mercury, you would see the sun rise and slowly grow larger in the sky. Then it would stop, move backward, and finally continue on its usual path. This strange movement happens because Mercury's slow spin can't keep up with its fast orbit. But why does Mercury spin so slowly? Scientists think it's because of a process called tidal locking. For billions of years, the sun's gravity has been slowing down Mercury's spin. Unlike our moon, which is completely tidally locked with Earth, Mercury is in a 3/2 spin-orbit resonance. This means it spins 3 times for every 2 orbits around the sun. This unusual day and night cycle creates harsh conditions on Mercury. One side of the planet faces extreme heat for months, while the other side stays in freezing darkness for just as long. The planet has something called an exosphere, a very thin atmosphere that constantly escapes into space and is replenished by sources like the solar wind, radioactive decay, and micrometeorite impacts. But this wasn't the biggest surprise. In 2020, studies using data from the Messenger spacecraft revealed that Mercury's exosphere has more water vapor than we thought. This water vapor probably comes from hydrogen in the solar wind, reacting with oxygen in Mercury's surface rocks. Another interesting aspect is how Mercury's long day and short year affect its magnetic field. Despite its small size and slow rotation, Mercury has a magnetic field, which scientists didn't expect. Recent studies suggest that this magnetic field is created by a special dynamo effect in Mercury's liquid metal core, influenced by the planet's unique orbit and spin. This weaker magnetic field is crucial for protecting Mercury from the solar wind. Without it, the solar wind would strip away Mercury's already thin atmosphere even faster. Mercury's fast orbit around the sun and its slow spin create some fascinating conditions. On its surface, there are places called hot poles, where the sun seems to stop moving in the sky. These spots are the hottest areas on the planet. On the other hand, there are regions near Mercury's poles that are always in darkness, never touched by sunlight. In these shadowed areas, scientists have found water ice, which makes us wonder, how can ice exist on a planet so close to the sun? The answer lies in Mercury's unique spin and movement. Some craters near the poles are permanently shaded, never getting any sunlight, which keeps them extremely cold. This is a big contrast to the burning hot areas nearby. The presence of water ice in these cold spots has led scientists to wonder if other materials like organic compounds might also be preserved there. Mercury's fast orbit brings unique challenges and questions. A path through space and time. Mercury's quick orbit around the sun, combined with its long days, affects how we study the planet. Its fast orbit makes it a tough target for spacecraft. To slow down enough to enter orbit around Mercury, spacecraft must follow complicated paths, including several flybys of Venus and Mercury. The Bepi-Colombo mission, launched in 2018, is on its way to Mercury, using these gravity assists to carefully adjust its path. It's expected to arrive in 2025 after completing 9 flybys. But that's not the most challenging part. Once Bepi-Colombo reaches Mercury, it will face the extreme conditions of Mercury's day-night cycle. The spacecraft will have to handle intense heat when it's facing the sun, and save energy during the long, freezing nights. Balancing these challenges is crucial for the mission's success and highlights the tough environment created by Mercury's unique orbit and rotation. Recent studies have also explored how Mercury came to have such a slow spin. It's possible that Mercury once spun much faster, but was slowed down by the sun's gravity and impacts from large objects like asteroids. This research helps us understand more about Mercury's past and gives us clues about how planets evolve in our solar system. But that's not all. New mysteries about Mercury keep emerging. For instance, how does Mercury's core stay partially molten despite its long, cold periods? How does its unusual orbit affect its geological features? These questions show that even in our own solar system, there's still a lot to learn. Mercury's unique characteristics challenge what we know about planet formation and push us to rethink our scientific ideas. One of the most intriguing things about Mercury is its unusually large core. Dr. Nancy Chabot from the Johns Hopkins Applied Physics Laboratory found that Mercury's core makes up about 85% of its total volume, much more than Earth's core, which is only about 15% of its volume. Why Mercury has such a large core is still a mystery. One idea, proposed by Dr. Eric Asfog from the University of Arizona, suggests that Mercury was once much larger, but lost most of its outer layers after a massive collision early in the solar system's history. This hit-and-run event might have stripped away much of Mercury's outer layers, leaving behind the dense iron-rich core we see today. Mercury's magnetic field is a surprising discovery, especially because it exists at all. Unlike Venus and Mars, which don't have magnetic fields, Mercury has one, though it's only about 1% as strong as Earth's. NASA's Messenger mission revealed this, leaving scientists puzzled. They didn't expect a small and slow-spinning planet like Mercury to have a magnetic field at all. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team found even more interesting details about Mercury's magnetic field. They discovered that it's not centered, but shifted by about 20% of the planet's radius. This could be due to differences in the thickness of Mercury's crust, which affects how heat flows inside the planet. But that's not all. In 2020, scientists announced that they found volatile substances like sulfur, potassium, and sodium on Mercury's surface. These materials usually disappear quickly under high heat, so finding them on a planet so close to the sun was unexpected. Dr. Patrick Poplawski from the Johns Hopkins Applied Physics Laboratory believes these elements might have been brought to Mercury by comets or asteroids after the planet was formed. Mercury keeps surprising us, revealing secrets from under its surface. Mercury's secret ice and the echoes of life. Another big surprise was the discovery of water ice in the craters near Mercury's poles, where shadows keep temperatures low enough to preserve ice. Dr. Nancy Chabot was instrumental in this finding. What's even more intriguing is that these craters also contain organic compounds, carbon-based molecules that might be similar to those that helped spark life on Earth. This raises the fascinating idea that Mercury might hold clues to the origins of life in our solar system. But the surprises don't stop there. For a long time, scientists thought Mercury was geologically inactive. However, the Messenger mission showed signs of recent volcanic activity. Dr. David Rothery from the Open University found small, bright areas on Mercury's surface that seem to be volcanic vents, suggesting that Mercury is still geologically active. If that wasn't enough, Mercury's southern pole has a region known as chaotic terrain, a vast area of jumbled hills and valleys as large as Texas. First observed by Mariner 10 in the 1970s, Dr. Thomas Waters from the Smithsonian Institution suggests that this chaotic terrain might have been caused by strong earthquakes, driven by the sun's gravitational pull as Mercury's orbit changed. Recently, scientists have also learned more about what's inside Mercury. Dr. Amir Khan from the University of Zurich analyzed data from the Messenger mission and found that Mercury has a liquid outer core and a solid inner core, much like Earth. But Mercury's inner core is much larger in proportion, which might explain its unusual magnetic field. These findings challenge our understanding of how planets form and evolve, reminding us that even in our own solar system, there's still so much we don't know. As we look forward to more missions and discoveries, it's exciting to think about what other secrets Mercury might hold beneath its surface. Who knows what we'll find next? One fascinating aspect of Mercury is the structure of its core. Unlike Earth, Mercury's core is mostly liquid with a solid part in the middle. NASA's Messenger mission discovered this by studying tiny changes in Mercury's gravity. The inner core of Mercury is quite large, stretching about 1,260 miles or 2,000 kilometers across. This makes up almost half of Mercury's entire core, which is much bigger proportionally than Earth's inner core, which only takes up about 20% of our planet's core. Mercury's core plays a key role in creating its magnetic field. While Mercury's magnetic field is weaker than Earth's, it's still surprisingly strong for such a small planet. Below its surface, Mercury has a mantle layer that is thinner than scientists originally thought. New findings suggest that Mercury's mantle is only about 260 miles, or 420 kilometers, thick. This is much thinner than Earth's mantle, which is about 1,800 miles, or 2,900 kilometers, thick. This thin mantle affects how heat moves inside Mercury and its geological activity. In 2012, an important discovery was made about Mercury's surface layers. The Messenger probe found evidence of ancient volcanic activity, including shallow indentations called hollows. These likely formed as certain materials escaped from the planet's surface. This suggests that Mercury may have had more of these volatile materials than previously thought. But this wasn't the most surprising discovery. In 2020, scientists studying Messenger's data found evidence of a massive ancient magma reservoir beneath Mercury's surface. This magma sea likely played a significant role in shaping Mercury's surface and interior. Diving deeper into Mercury shows a possibly vibrant past, exposing a hidden history. This ancient magma sea might also explain some of the unique features on Mercury's surface, such as the large, flat areas known as the northern volcanic plains. These plains probably formed from large lava flows early in the planet's history. One of the most remarkable discoveries came in 2022 when researchers found evidence of nitrogen beneath the surface. This nitrogen might be left over from an ancient atmosphere that was pushed underground by the planet's intense heat and solar energy. This finding raises interesting questions about Mercury's past climate and whether it might have once been more hospitable. These craters are shielded from sunlight and contain ice that might have come from comet or asteroid impacts in recent millions of years. Along with water, these craters may also contain dark deposits that could be organic compounds. These materials, which are possibly even more volatile than the water ice, likely came from cometary or asteroid impacts. Their presence on Mercury offers a unique opportunity to study how organic compounds are distributed in our solar system. But that's not all. Mercury's structure also reveals its complex history. Even though Mercury doesn't have plate tectonics like Earth, it shows signs of significant shrinking as it has cooled, leading to many surface faults. These geological features add yet another layer to our understanding of this unique and complex planet. On Mercury, where one part of the ground pushes above another, we see large cracks that reveal what's beneath the planet's surface. These cracks give us clues about Mercury's geological history. In 2019, a study made an interesting discovery. Mercury might still be geologically active. They found small valleys, called grabens, near these big cracks. Grabens form when the ground stretches, and these look quite new. This suggests that Mercury's ground is still shifting and changing. Another fascinating aspect of Mercury is its magnetic field, which doesn't work like Earth's. On Earth, the magnetic field comes from molten iron swirling in its outer core. But on Mercury, it seems to come from a different source. Some scientists believe it could be caused by a layer of liquid metal around a solid core, acting like a dynamo. There's also speculation about cracks and breaks under Mercury's surface that might allow heat and maybe even liquids to move through the ground. While Mercury's surface is dry, some scientists think there could be spots of water deep below, kept from freezing by the planet's leftover heat. It might sound surprising, but we've seen similar things on other harsh worlds, like Jupiter's moon Europa and Saturn's moon Enceladus, which both have oceans hidden beneath icy surfaces. So the idea of water beneath Mercury's surface isn't entirely out of the question. But this isn't the only mystery Mercury holds. Studying these hidden areas raises many questions. How has Mercury's inner structure changed over time? Could there be other volatile substances under its surface? And what can these tell us about the early days of our solar system and the formation of planets? These questions make it important to keep exploring Mercury. Every new discovery about its hidden depths not only adds to our understanding of this intriguing planet, but also offers insights into how planets form and evolve in our solar system. As we think about future space missions and the potential discoveries they could bring, it's clear that Mercury, despite being small and close to the Sun, holds many secrets. Its hidden layers might just offer clues about its past and even the broader history of our solar system. What do you think lies beneath Mercury's surface? Could it change our understanding of the solar system? Comment your thoughts and subscribe for more.